All right. I want to welcome everyone to our session today. My name is Ernest Jackson. I am a CSE in the GSO Channels team. I want to welcome everyone to our first delivery of the SEVT mini-series. Today we're going to be covering ICE and StealthWatch messaging, positioning, and design. We are not going to go into roadmap or futures. This will be covered at the Security SEVT coming up the week of April 8th, so please refrain from asking those types of questions. Today we're going to have two presenters from the Networking and Security Business Group. We're going to have Tim Abbott, who is an ICE TME, and Peter Johnson, who is a StealthWatch TME. So before we get started, a few quick housekeeping items. As we always have, we have an illustrious group of panelists here who can answer your questions during the session. So please use the Q&A panel. Don't use the chat window or jabber directly to folks. So please, we want to make sure that we can have those questions and answers recorded. So please make sure to use that panel. We're going to be going for about 90 minutes. Towards the end of the call, we're going to have a survey. We would ask for you guys to fill out that survey because we want to take that information back and try to improve the sessions or put the right kind of information out for you guys. So we will be recording this call, and it will be posted to Sales Connect within 7 to 9 business days after this call. So just keep an eye out for that, and we will have that posted as quickly as possible. All right, with that, I believe I am now done. So Tim, I'm going to hand over to you. Take it away.
All right, thank you. Hopefully everybody can hear me okay, and hopefully everybody can see the slides that I've got up here so far. Again, my name is Tim Abbott. I'm a technical marketing engineer with the Secure Policy and Access Group at Cisco. And today I'm here to talk to you about Cisco Identity Services Engine. So with that, let's go ahead and dive right in. So what we're talking about is Cisco ICE and AnyConnect. So what's Cisco ICE? It is a context-aware policy platform that allows controlled access to your network, as well as providing threat information with integrations for wired, wireless, and VPN networks. Cisco AnyConnect, at its core, it does VPN access, but it does so much more than just that, right? It does services such as posture assessment, malware protection, web security, and more. And we're going to talk about that in this part of the presentation here. So what I wanted you to take away from this slide is we do take in a lot of context, the who, the what, the when. We also integrate with the PX Grid and APIs to bring in partner ecosystem information, and we can then make intelligent access control decisions based upon that information for your wired, wireless, and VPN networks. So what we're doing here is we're managing policy based upon trust, right? So ICE provides the improved visibility and decision-making of the endpoints that are connecting to your network in terms of the device type, where that device is accessing the network from, what time they're accessing the network, what's the vulnerability information look like, what's the threat information, posture assessment, et cetera. And what we can do is then we can take this information, we can use it in software-defined segmentation, so we can determine who and what kind of device type has access to our trusted information, our protected resources in the data center, and we can also extend that information out into the cloud, right? So we can look at things like Salesforce services, SharePoint, et cetera, and we can extend that protection off premises and in the cloud, okay? Let's see here. Let's move on to the next slide here. This WebEx does not want to behave for me. There we go. Use cases. So what are some of the ICE use cases? Well, aside from just authenticating users and devices to the network, it does a number of different things. It provides visibility. It shows customers what's connecting to their network. It provides next-generation access control and software-defined segmentation to protect your critical resources on the network, right? It does guest access in a very simplified, fluid manner, on box. What you see is what you get, corporate branding, easily done right there on box with ICE. It's a closed-loop, easily managed guest access system. With TrustSec, we can do DEFCON-type policy enforcement where I maybe have a standard policy, but in the event of a malware outbreak or some ransomware, what have you, I can quickly lock the network down, prevent any east-west traffic from spreading throughout the network. We've got always-on policy compliance as well as rapid threat containment and a very large and growing ecosystem. So let's dive first into visibility and what does that mean? Well, ICE while it's doing its next-gen access control, it's also collecting a bunch of information about that user and that device on the network. And we're going to talk about how it does that in the next set of slides here. Okay. This is hopefully you can see this well. This is actually a screenshot of a live environment where ICE is deployed, and we kind of give you a view of the number of devices that ICE has seen on the network, the number of active authentications, the BYOD devices, any type of system information, what our node statuses are, et cetera, as well as compliance information too right there in front. So it gives you a lot of information just by logging in, and if you want to get more detail, you can drill down into that even further, okay? If you want to quickly get visibility, you can use something called the Visibility Setup Wizard. So right up over here in the upper right-hand corner, you can click on that little user icon and launch the Visibility Setup Wizard. It's a quick 3-step process that will not only discover your endpoints on the network, but it will also import any network access devices into the system as well, and it will also join Active Directories for you. So it actually automates a couple of setup processes for you, so you don't have to go and manually do that. And then it will show you what it's discovered, okay? So not only does it show you the endpoints, but it will also bring in your network devices. All you have to do is give it a management network or an IP range and give it a SNMP community string, and we can import those devices in there for you, tell you the location of, I'll give you the ability to find the location and any other SNMP information that we do get from those network access devices, okay? And once the Visibility Setup Wizard has run, what it does is it drops you into something called Context Visibility. Context Visibility is a relatively new feature in ICE that allows you to get further information about your endpoints on the system. It's got the tab-based type of mechanism to navigate through it. It has a number of different dashlets based upon the type of information that you want to use. These are all customizable. And then at the very bottom of Context Visibility, it has a table that dynamically updates based upon the information that you're looking for. So if I want to drill down and say I'm looking for Apple devices, and so I click on the OUI and the dashlet for Apple devices, you'll see a breadcrumb that'll show up. And then maybe I'm just looking for iPhones. Well, I can then click on the endpoint type of iPhones. And then not only is the breadcrumb trail getting larger, but it's dynamically updating that table at the bottom. So that what ICE is doing is then showing you all of those iPhones that ICE has picked up on the system, okay? So just to kind of give you an overview again, of what Context Visibility looks like. So here's a screenshot, again, of a live system. And so at the top, we have our different tab types. We have authentication, BYOD, compliance. So if you're looking for specific sets of information, we compile these for you in these different tabs. So in this example here, we're looking at endpoint classification. And underneath that, what we're looking at is endpoints, endpoint categories, and network devices. Furthermore, we can adjust the information that these dashlets are seeing based upon categories underneath that. So if we want to look at endpoint types or we want to look at profiles, we can adjust that. If we want to look for just OUIs or maybe just OS types, we can adjust that as well. And keep in mind, as I'm doing these and I'm interacting with these dashlets, right, I can actually click on the various sections of those pie charts that will allow me then to dynamically update that table at the bottom that shows all of those devices. At the same time, I'm creating a breadcrumb trail that I can save for future reference if I need to. So it provides a lot of information for network administrators and customers to get pretty quickly, and it's very, very valuable. Okay. So how does ICE get all that information? Well, yeah, we have the Visibility Setup Wizard, and at the same time, it's also dependent upon something called ICE profiling. So at a high level, ICE has the ability to learn about up to 1.5 million devices on the network, and each of those can have up to 50 attributes. So that's a lot of information that it can store, right? So when we get these devices onto the network and we start profiling, we can, out of the box, we've got 550 pre-canned, pre-designed profile policies already available to you. So the system, once it's connected to the network, installed in the network, it can automatically go out and start profiling a large number of device types. And not only that, we also have over 250 plus medical device profiles that are available. So depending on the environment in which ICE is operating, so say if it's in a medical environment, we can also talk to you about those internet-connected IV pumps and heart monitors and things of that nature. We can tell you where they are, how they're connected, etc. So in addition to all of the different probes that ICE has, from DHCP, user agent string, all of these things that ICE uses to collect information, ICE goes down into the weeds. Using AnyConnect, it can also show you things like application visibility. It gives you applications. So what applications are running on my endpoints? What applications are running on my Macs or my Windows machines, right? So we can actually go and every 5 minutes pull these devices using AnyConnect to then see what kind of applications are running on the system, okay? We can see what's running. We can see what's installed. So we give you a lot of flexibility. And even in newer versions of ICE, we also provide you the ability to look at hardware as well. So we can give you serial numbers, et cetera. So it's really turned into this awesome system in which we can not only provide you your context information of who's on that device, what kind of device is it, but we can also tell you about the applications that device is running, as well as the hardware that endpoint has. So it's really, really granular. Over time, ICE has evolved. If you haven't seen newer versions of ICE, it has really evolved into something extremely powerful from a visibility point of view. So looking at application visibility using AnyConnect, we also have a module that AnyConnect can use called the Network Visibility Module. So whether I'm on-prem, I can use this module here to then see what my endpoint's doing, what resources is it using on the corporate network or the public network. So AnyConnect can transmit that information to our NetFlow collector, and then at that point provide really detailed information about what kind of traffic that endpoint is actually accessing on the network. So it gives another aspect of visibility in terms of what your endpoints are doing on the network and how much time they're spending at various locations, et cetera. Sometimes the website does not want to work from. There we go. Okay. Something new that we introduced in ICE 2.2 is called the ICE Passive Identity Connector, or ICE PIC. Okay. ICE PIC is essentially a how do I explain it? It's a subset of ICE features. ICE PIC is ICE, but it is a subset of those features. With ICE PIC, we give you the ability to passively learn about identity without having to be in the middle. There's this concept of active authentication versus passive authentication, which I'll talk about later on. But ICE PIC passively learns using a number of different probes information about users on the network, and then can share that information using PXGrid to then allow other network services such as StealthWatch and FMC to then make a decision on that identity information based upon its behavior. So ICE PIC and ICE, we're using passive identity. We have a number of different probes for integration with Active Directory, and those include WMI, Kerberos Span, and we can also have a dedicated agent that can run on a controller. ICE and ICE PIC also has the ability to consume syslog. So anything that can give us a user to IP mapping, we can basically, as long as it's an RFC compliant syslog message, we can take that information and then build an identity, build a session, and then over PXGrid be able to share that information out. For virtual environments, we have a REST API that allows Citrix and Microsoft Terminal Services to then share not only the user to IP mapping, but as well as the port information. Because if you recall, in virtual environments, there can be more than one person behind a specific IP address. So via that REST API, we can then also learn about who's at the IP address and what port they're using as well. And then lastly, what do we do to figure out if a user is still actually at that IP address? Because essentially when we're doing passive identity, we're trying to understand who the user is and what IP address are they at. Now, people move, they disconnect, they connect, and these things are fluid. They change over time. So what we needed to do was build a mechanism that would allow us to then prune our session directory in the event that a user logged off or left the network. So this is what we did. This is what we had in mind when we developed the endpoint probe. But what this does is ICE and ICE PIC will use this probe to actually go out to the IP address and query that endpoint to see if the user is still logged on. If it's not, then what it will do is remove that session from the session directory. So at its core, ICE, again, it's a radius server, and it's really kind of its bread and butter is actually access control, right? So what it does, it gives you the ability to essentially take your policy, your security policy, and enforce it during when folks are actually connecting and authenticating to the network. So what we do is based upon these context data of the who, the what, the when, the where, et cetera, we then are able to assign some kind of authorization result based upon what they're entitled to. So is it a BYOD kind of use case? Is it basic? I'm just going to authenticate them because they have valid credentials. Are they guests, right? And then what kind of resources am I going to allow them to do that? And then using PXGrid, I can also share that information out to other network resources such as StealthWatch or FMC, et cetera, okay? So ICE can be actually deployed either in a physical form factor, such as our UCS-based secure network services appliances, or they can also be installed as a virtual machine as well, okay? So what does our access control kind of look like? Well, we talked about it working across, three main silos of wired, wireless, and VPN, okay? So ICE can use either native supplicants of endpoints or using supplicants such as Cisco AnyConnect. We can support up to 500,000 concurrent connections, okay? 500,000 active sessions, 500,000 people connected to the network. ICE supports up to 100,000 network access devices, so 100,000 routers, switches, wireless LAN controllers, VPN concentrators, et cetera. ICE can allow network administrators to accumulate up to 300,000 internal users, right? Or it can just go ahead and use an external identity source such as an SQL server, an LDAP server, or more popularly Active Directory. And those join points for Active Directory can be up to 50, and they don't have to have two-way trust. We support multi-forest environments and multi-domains as well. Okay, and I talked a little bit about it previously, but this concept of active identity versus passive identity. So when we're talking about active identity, ICE, participating in Radius 802.1x, right? The network access device is giving us these credentials for validation. Whether we're sending those to Active Directory or not, we actually learn the identity that way. When we're doing passive identity, we can do things like Easy Connect, where we're just doing a MAC authentication bypass scenario. But then I also need to figure out who is at that device. And we're going to talk a little bit more about Easy Connect later on, okay? So when we're authenticating these users, we have the ability to use a number of different things. We can use external sources such as Active Directory, or we can also do SQL server or an LDAP server, right? We can also issue certificates for these endpoints. So if we want to do ETLS or something of that nature, we can integrate with a customer's enterprise PKI, and we can issue certificates to those endpoints on behalf of that enterprise PKI. ICE also has an internal certificate authority as well. So if customers would like to have a kind of a closed loop type of BYOD solution or a turnkey solution, ICE can issue certificates from its own internal certificate authority and issue certificates that way, right? ICE can also be a subordinate to the enterprise PKI and issue certificates that way. So ICE gives customers a lot of different ways to provide flexible authentication mechanisms, okay? So once we have this identity, we can share this information to SAML IDPs. So any SAML version 2 compliant IDP is what we can work with. So we have this kind of single sign-on type of approach. So anything that's compliant with SAML v2, we integrate with. And again, using these types of authentications, we can then provide the authorization results, which can be in the form of a downloadable ACL. We can use on-box ACLs or named ACLs that are present on like a wireless LAN controller or on a switch. We can also assign what's called a scalable group tag. It's also known as security group tag. And we can do a number of different things based upon the customer's desire for how to enforce their policy. We also do the traditional VLANs. However, I'm going to talk about in a little bit later how we can scale further than that using TrustSec. Okay. So what about those devices that can't do 802.1x, right? 802.1x has been around for a while. A lot of customers are already doing it in the form of wireless 802.1x. Many of them are starting to now migrate to a wired type of solution. But what do we do about those devices that can't participate? They don't have a supplicant, right? this is where we bring in something called MAC authentication bypass. Now, MAC auth bypass was something that was developed to be kind of a Band-Aid solution. Ultimately, we want customers to go to 802.1x because it's a more secure authentication mechanism. So if they don't have that, we can do something called MAC auth bypass. And basically, let's see how this works. What happens is the network device is asking over EAP to, hey, give me your credentials. This device, not having a supplicant, doesn't know how to respond to that. So what it does is what it normally does on the network. It's going to request a DHCP, or it's going to request an IP address from a DHCP server, and that's when we actually learn about the MAC address. So the network device then sends that up to ICE and then can do a couple of different things with it. It can let it on the network, it can deny it, it can do other stuff, but that's when ICE learns about the MAC address. Now, when we couple this with profiling, ICE can not only build this database, but we can also classify it at the same time. So it's a really powerful solution in terms, especially when you couple that with profiling. Okay, so Easy Connect, we talked about that being a kind of a passive ID, passive authentication type of solution. So we've got three main options for customers that want to authenticate devices. We have our most secure, which is Radius 802.1x, and we have our least secure, which is MAC authentication bypass. Now, some customers don't want, for whatever reason, to deploy 802.1x, but aren't comfortable with just using MAB in of itself. So what we decided to do was build something called Easy Connect. Well, what Easy Connect does is, if I get the slides to animate here for you, what we have is a device that's not configured for 802.1x. This could be, it could be anything, right? It could be, let's say it's a workstation that's just not set up for authentication. It could be a BYOD device or what have you. Maybe it's adjoined to the domain, but it's not configured, and they don't want to play around with 802.1x. What happens is they connect to the network. They get their IP address. They have access to NTP, and, DNS, and Active Directory. So this is like a limited access. So once it connects, ICE provides a limited access type of authorization to this endpoint. What it also does is it then allows the user to actually log on. So he sits down, it's Control-Alt-Delete on the keyboard, and actually logs on to the domain. Now, keep in mind, this isn't 802.1x, so ICE does not see these credentials. These credentials go up against the Active Directory domain controller. What happens then is ICE is informed by the domain controller that, hey, user Bob is at this IP address. There's a successful authentication of Bob at this IP address. What ICE then does is say, okay, what am I allowed Bob to have? Is he supposed to be a part? What group is he a part of? Well, he's actually an employee with the company, and so we now validated his identity, and now we're going to go ahead and then send a COA to that switch and then allow full access. So here, what we've done is we've allowed customers to get their devices on the network without having to deploy 802.1x. So it's actually a much more secure solution than just using MAB. We still get identity from a trusted source in Active Directory and can also still provide the visibility without just using MAB by itself. So we also have something called the ICE Deployment Assistant, or IDA. What this does is it allows customers and partners to go in and kind of assess their network infrastructure and see, based upon the use cases that they want, this will go out and tell customers, hey, this switch is capable of these types of use cases. However, you might want to look at the software version that you're currently running. So maybe the software is outdated. Maybe I'm trying to figure out if my infrastructure will support wired BYOD or something of that nature. This solution will allow customers and partners to go out there and do that. It also allows for the configuration of network access devices, as well as the ability to troubleshoot failed authentications. Okay. So we talked about authentication. Let's talk about authorization. Essentially, there's three major options for when we do access control. There is the downloadable ACL or named ACL. So a downloadable ACL is obviously something that when we do an authentication and we send down an authorization result, it's an access list that sits inside of ICE, which can be centrally managed across the infrastructure, and is then sent down to the switch as part of an authorization result. If for whatever reason we've already got ACLs that are already managed and they're already out and deployed throughout the network, we can actually use the ones that are already pre-configured on the switch, whether that's wired or whether that's wireless. So if we look at wireless LAN controllers, they don't support downloadable ACLs today, so we can actually reference that named ACL on the controller. we can do traditional dynamic VLAN assignments. So if I need to, if I got an IP phone that's authenticating, I can go ahead and put it in a voice VLAN. You know, is it a guest? Are these guest credentials that I've got? Well, I can send down a guest VLAN authorization result. And then lastly, what scales a lot more is what's called security group tags or scalable group tags. So not only can I send down a downloadable ACL or a VLAN, I can also send down a TrustSec security group tag. So previously, ICE has been accused of not being able to play well with third party. And let's kind of walk through that. When we started with ICE 1.0, we've always been a standards-based radius server, and we've always been RFC compliant for that. So starting with 1.0, we could always do 802.1x with any piece of infrastructure that supported that, right, that standard. Now with ICE 2.1 and newer, we have enhanced support for third-party network devices to include our popular features such as profiling, posture assessment, guest, and BYOD. And the reason why that is because over time, a lot of these third-party infrastructure has started to build in essential radius features that we need to be able to support some of these more advanced use cases. And particularly, it's radius change of authorization and then URL redirect with a session ID. And there's many of these third-party vendors that are building this functionality into their third-party infrastructure. And with that, ICE has also now been able to enhance that capability. So it doesn't have to be an all Cisco network. We can work with Aruba, Motorola, Hewlett-Packard, or Brocade, etc. So software-defined segmentation, kind of want to talk about what that is here for a minute. And what it is that we've got all of these devices and users on the network. And I need to figure out how they're going to interact not only with each other or how they're going to interoperate with within the group or maybe with outside of the group. How does that look? How can I protect it going forward? So what we do is we can use something called security group tags, and we can group this together. Rather than assigning an ACL for each and having to maintain that ACL, what we can do is use group-based policy to assign tags, which then allows me to not only determine whether or not members of a particular group can communicate with each other, but can they communicate with important things like finance servers, that type of information. If I've got various types of users and devices on the network, say I've got an Internet of Things type of building management or lighting system or something like that, these devices do not need to have access to our finance servers. So we can build this type of group-based policy, and then using next-gen firewalls in the network, we can enforce it. We're going to talk a little bit more about how that looks here soon. Okay? So segmentation with TrustSec, and this is really kind of what I'm getting to when I was talking about group-based segmentation in the previous slide. So traditional segmentation has been VLAN-based, and if you ever run a network previously, it can be a challenge, right? Because we have to somehow stretch those VLANs across the network. And really, from a design perspective, being networkers that we are, that doesn't really scale, and it's really hard to type of maintain, right? So we have to maintain all of these different VLANs for all these different types of groups, whether they're employees or whether they're guests or whether they're printers or what have you, right? But with TrustSec, I don't really need to do that. I can maybe have one or two VLANs. I can have a voice VLAN and maybe just a data VLAN. So I put all my IP phones in the voice VLAN for QoS purposes on the switch, but I can leave everybody else in one VLAN, just the one data VLAN. And by using TrustSec, what I can do is then assign a tag to each one of those devices, and then I can then prevent whether they communicate. Guests can communicate to employees, whether employees can talk to other employees, etc. So I can also control what level of access different employees have to resources in the data center. So it really allows me to scale, right, in an intelligent manner rather than just using traditional ACLs as well and VLANs. Okay? So with using ICE as the kind of centerpiece for policy, right, we have the ability to make sense of what all these tags mean. And we have something called the matrix, the TrustSec matrix inside of ICE. And here's where we can define what those tags mean and how they can communicate across the network. So here in this example I'm showing you, I've got a guest tag where I say, you know what, they don't need to have access to the company database, the public cloud, the external server, just give them the internet, right? That's all we need. And I can do this for every single group that I have and that I need to consider on my network. So employees using BYOD, maybe I don't want them to have access to the company database either, right? Building management, maybe I need to allow that for whatever reason, or employees, okay? So here I can get in very granularly to determine who can talk to who and who can talk to what type of resource. So that from a very a group-based type of policy approach, I can simplify these roles and I can apply them automatically, and it allows me to scale to large degrees. So with TrustSec, we generally have three types of use cases when we're doing TrustSec deployments. We have a user to data center and cloud access control type of solution. We have a campus and branch segmentation solution, and then we have a data center segmentation. So user to data center is, like I said, pretty self-explanatory. So I got a user that connects to an access switch, and I've got to access, resources in my data center or something out onto the cloud. Campus and branch is where I've got, it's more or less kind of an east-west type of traffic solution where I've got employees that are connected to one office, and for whatever reason, they're got to communicate to other employees at another office, right? Maybe that's a jabber session, or it's an IP telephony call, or what have you. And then inside of the data center, I can further segment using TrustSec, whereas I can have resources to database servers can talk to certain other servers that need to have that kind of connection, and I can prevent other servers, prevent them from talking to my finance or PCI compliant infrastructure. So when we talk about campus and branch segmentation, that stretches across the network and allows for us to enforce this single source of truth in the TrustSec policy, where I've got employees, regardless of if they're at remote site 1 or remote site 2, or if they're inside of remote site 1, whether or not that they can talk to each other, and what can they access inside the data center as well. So I've got the ability not only to do that from a micro-segmentation, like a type of on-switch inside of the same VLAN approach, but I can do that enterprise-wide. So user to cloud access control, kind of talked about this a little bit already, where I've got my devices that are connecting to my network access, my switches, my access switches, and I'm doing my dynamic assignment right there. And then as they travel upstream, or they're trying to access on-premise resources, maybe the finance or servers or the human resource servers, I can go ahead and protect those resources based upon what their authorization is per our policy. And this policy, again, can be painted across not only my on-prem solution, my on-prem services, but as well as in the cloud using services such as ASAV or your ISRV. And so we have this single pane of glass that can not only work with my enterprise network on-prem, but it can also be extended to my cloud providers like Amazon Web Services or Microsoft Azure. So in addition to just the enterprise network, where we can do our user to data center and cloud, and our campus to branch and intra data center segmentation, if I've got customers that have adopted ACI and have deployed that into the data center, TrustSec and ICE can also work across those ACI domains as well. So we have these EPGs inside of our ACI domain, and those, when we integrate those with ICE, can be transferred to ICE. So ICE becomes ACI aware of those EPGs, as well as the fact that my TrustSec groups that I've defined on ICE, those can be sent over to my ACI domain as well. So we can have a single pane of glass in terms of policy, whereas I've got my enterprise network, but I've also got my data center policies, and those can be all in line from a policy point of view. So I've talked about the TrustSec policy matrix, and I've talked about different source and different destination types. So if we look at what the TrustSec policy matrix does, what we do here is on the left, we've got our source tags, right? We've got our source groups, and these can be different tag numbers, 3, 4, 5, 6, all the way up to a huge number of different tags. This is our source. And then we also have at the top row is our destination. Now, from a macro level, what we can do is we can say, okay, auditors, they don't have the ability to talk to these resources on the network, or we have these developers and they can't talk to this. So that's sometimes what I'm talking about here is I've got tag 3 can't talk to tag 5. All right, so this group of developers with security group tag 3 can't talk to production servers, which is tag 5. Okay, but what if for some reason I need to have my developers talk to the production servers, but in a limited form. What I can do is I can deploy something called an SGACL. An SGACL is a security group-based access control list. And what I do here is inside of my TrustSec policy matrix, inside the box for the source and destination, what I can do is assign the ACL in which the ports that I can allow my traffic to be communicated. So let's say for whatever reason the developers need to access the production servers, but only on a specific set of ports, I can allow that and drop every other piece of traffic. So, and again, this provides another level of granularity for our customers when deploying TrustSec. If you've ever had to maintain access lists on a firewall, then you know that over time, those things can get really, 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 really big. And also, unless they're well documented, people will forget exactly what these ACEs or access control entries actually mean, and do I need to have those anymore? And these can grow huge on firewalls. So how do we solve for that problem? Well, again, using TrustSec, we don't need to worry about IP address ranges or a source IP talking to a destination IP and what is that a permit or deny type of functionality. Using TrustSec, we're actually using groups instead. So where I'm grouping a type of people together, and then I can say based upon identity, I can say, my employees are allowed to talk to these servers, or my finance people are allowed to talk to the finance service. It's from a group-based type of point of view. I'm not having to worry about maintaining IP addresses any longer. I just have to worry about maintaining who can talk to what, basically. So, and in some cases, we've seen that we can reduce firewall access control lists by as much as 80%, which is a pretty significant number. So it makes it a lot less complex, and it's a lot more. It gives administrators and firewall administrators a better way to understand what my firewall is doing, what it's configured to protect against at the current time. And then if I need to go back and take a look at it in the future, then okay, well, we don't have these groups anymore. This group of contractors have done their work. They don't need to talk to these servers anymore. I can go ahead and remove that from the firewall. So firepower threat defense can also leverage TrustSec, which is really, really exciting as well. So FTD or FMC can actually, over PX Grid, subscribe to the TrustSec metadata topic. And it can pull down all of my security group tags that I've got configured for TrustSec inside of ICE. And it can then use that information to define its own set of policies. And if one of those policies are violated, FMC can then actually go out and then actually do an enforcement mechanism on that. And I'm actually going to talk about that a little bit later on in this presentation. So ASA with firepower services at the same time can also do inspection based on SGTs. So if I have particular traffic that ICE is assigned, maybe based on threat or vulnerability information, what I can do is I can have rules set in ASA with firepower to then do some inspection or do something with that traffic as it comes through the firewall. So recently we introduced something called multiple matrices with ICE, and in the past we've always had just one matrix. But what if I need to change that for some reason, right? What if I have to, for whatever reason, I need to lock down my policies? Well, I have the ability to then set up I have multiple versions of my policy. I can have our standard operating policy for its day-to-day, everything's hunky-dory and normal policy. And then I can have a policy that say maybe, something really bad has happened on the network or something is spreading across the network and I really need to apply something that's going to lock everything down. So we can apply risk-based policy based upon what's going on in the network. And again, it doesn't require us to kind of forklift our policy because I can have them predefined. And then it provides flexibility. So let's say maybe I want to have a policy for a specific site. So if I want to have a London-based policy or I want to have a New York-based policy, I can have all of these different policies set up, which provides much more flexibility to our customers. So I kind of talked about it a little bit, let's say like with DEFCON policy sets. So like I said, I've got a standard operating policy where everything's fine. Employees can actually interoperate with each other. They can send communicate between each other, and they can get access to various resources in the data center. But in the event that I detect something, that's gone on, or maybe ransomware's starting to spread, or some other form of malware, what I can do is I can deploy a more stringent policy set and immediately start locking down the network, which I basically can restrict all lateral movement. So employees can't talk to each other, while at the same time they can still do our normal operation. So I'm not preventing them from accessing the resources in the data center, but I'm preventing that east-west spread of malware, right? So this is something that allows our customers to very quickly and efficiently deploy a policy for, scenarios in which I've got to do something quick because something's bad's happening on the network. All right, so let's shift a little bit from TrustSec to policy compliance, right? Now, policy compliance, when we talk about compliance, we're talking about a couple of different things here. We're talking about posture assessment, and compliance has a couple of different forms, and we're going to go through that in this presentation. So what we're doing is here, we're authenticating the device, and based upon the information we get, we can quarantine it. We can do that in a number of different ways. We've talked about authorization. When we do the assessment, we can check for things like hot fixes, antivirus, etc. And then we could also launch remediation actions where we force the client to update itself, etc. And then if we're all happy at that point, based upon policy, I can go ahead and let them on the network. So this is an always happen, always on type of approach. So when we're doing a posture assessment with ICE, there's a couple of different options. For our desktop or laptop type devices, we can use Cisco AnyConnect standard mode, which is, again, you see a little icon up there in the upper right-hand corner of your screen or in your system tray. Or we have something called AnyConnect stealth mode, which is AnyConnect is still running in the background, and you'll see it running as a process, and it's doing its posture assessment, but the end user doesn't have any way to know that it's actually doing anything. And for contractors or people that I don't really need to have to worry about because that endpoint doesn't belong to me, I can still do posture assessment through like a temporal agent or a web agent, or dissolvable agent, if you will. Okay. So like I said in the beginning of the presentation, AnyConnect does a lot more than just VPN. Okay, it does a whole bunch of other stuff. It does endpoint compliance with ICE posture. It does inspection services. It provides access in the fact that it can participate in 802.1x. But it also does threat protection. It gives visibility, as well as it has the ability to provide for open DNS. So there's a number of different add-on features for AnyConnect that can really shore up, from a security perspective, customers' networks. Okay. Now, how do we do that? How can we deploy AnyConnect? Well, there's a number of different ways to do it, but if we're looking at it in the context of ICE, what we can do is then we could take an endpoint here, understand a couple of things about it, what the operating system is. We learn about the browser and the version of that operating system, who the user is, right, or some other attributes. And based upon that information, we can then apply our client resources to that endpoint, right? So once we understand what the device is and who the user of that device is, we can then make an intelligent decision. Okay, these are the things that we want to deploy to that endpoint for posture assessment. Okay, and then once that's done, our agent runs and provides all of the compliance data that we need to make an intelligent decision about it. If we're talking about mobile devices, we can use kind of native supplicant profiles for Apple devices, etc. So what about posture policy, or how do I enforce this in authorization? Well, it's actually really, really simple. And using very, very specific, easy rules here, and I'm going to highlight those for you. I've got two rules. If you're compliant, so if the posture status is compliant, I'm going to give you permit. I'm going to permit access. Right? Obviously, I can be more granular than if I want to, but here I'm doing something very, very simple and basic. And if you're not, so if your posture status does not equal compliant, well, then I'm going to do something else with you. So it's very, very easy to go ahead and add this into authorization policy. So it's not as complex as it may seem. Remediation, okay, we can do a number of different things here, from looking at antivirus and anti-spiral remediation. We can see if that functionality is enabled. We can install missing patches. We can activate patch management software that's already installed and force the update that way. So ICE posture does provide a number of different things to interoperate, and enforce that compliance. In addition to, the compliance, we can also do an advanced malware protection enablement as well. So not only can we provide, the client provisioning for posture assessment, we can also provide for VPN configuration. We can also provide for AMP enabler as well. So if I've got AMP, I can actually tell ICE, hey, if this device doesn't have AMP installed, here's where I need you to go get that software, and then here's where I need you to install it, okay? So for these devices, here's the location. I need you to grab that software and then install it onto the system. So right inside of AnyConnect, we can also deploy the AMP module as well. So starting with ICE 2.1, ICE integrates with SCCM. So what we can do in an MDM type of flow, we can actually have ICE communicate with SCCM over WMI to retrieve information about a current device. We can see if it's registered or if it's registered non-compliant versus compliant. And so it provides another level of information for ICE and our policy to then do something about that endpoint. If it's not compliant, then I need to do something to get it up to date. And if it's compliant, we can let it know. So that's another integration that allows for more flexibility in terms of compliance. Okay. We've also introduced something called threat-centric NAC. And let's first talk about what that does. So here the problem is I've got a malware infection. So I've got an endpoint that's been infected with some form of malware. What it does is it goes and it scans for other vulnerable endpoints. And once it detects one, it goes and it then spreads that infection across the network. And before you know it, everything's going to be infected. Well, how can we prevent that? Well, if I'm using AMP or Qualys, what happens is Cisco AMP will detect that a threat is present on the device and will send that indication of compromise to ICE, in which ICE can then do some form of quarantine action against that endpoint and then prevent the further spread of that malware across the network. If my customer is using a solution like Qualys, what we can do is then trigger maybe a vulnerability scan against that endpoint, and then Qualys will then give us that CDSS score, and based upon that information, we can quarantine or remediate that endpoint. So that's what a threat-centric NAC does for us. So again, using threat-centric NAC, again, it's an additional level of context that we're then providing. So based upon the information that we can get from either AMP or Qualys using STIX, CDSS and IOC, or vulnerability assessments, we can then add on another layer of context in terms of threat and vulnerability. So when we talk about compliance, traditionally that's like from a posture assessment, where we've gone and we've scanned the endpoints and said, oh, well, your antivirus is out of date. But now with threat-centric NAC, we can actually look at it from a vulnerability and a threat perspective and then make intelligent decisions about access control based upon that information as well. Okay. With ICE 2.2, we've expanded our support for that in the terms of Rapid7, Tenable Nessus, and cognitive threat analytics as well. So what does CTA look like? So here, if you go into context visibility, you can see we provide endpoints that have been compromised. We can also show the course of action for those endpoints. And again, if I'm looking for that, as I'm working with these charts, my table at the bottom of context visibility will dynamically update. And moreover, I can then do something about it. So if I have a particular endpoint, I can actually do a change of authorization against it and do other actions. So we've talked about laptops, we've talked about desktops, right? But with the advent of mobile devices, we need to have an answer for that as well. So what does that look like? Well, mobile devices are prolific in all customer networks now. So how can we look at that from a posture perspective? To get compliance information, customers need to use something called an MDM, a mobile device management platform, right? And those are things like Mobile Iron Good, Cisco Meraki, AirWatch, etc. So what we can do is, if we're integrated with a mobile device, we can integrate with an MDM, the flow looks like this. We have the device register with ICE, and we can give them internet access. Now, if my policy requires it, I can force that device to register with the MDM, and then at that point get compliance information from that. And those compliance checks can be in the forms of whether or not they're just registered, what's the encryption status of the disk, does it have a PIN lock, is it jailbroken, etc. And if it meets my MDM compliance security policy, I can then allow it access to the corporate network. So that's kind of how the flow works with mobile device posture. Now, I talked a little bit about FMC previously, where the FMC can actually subscribe over PXGrid to the TrustSec topic. we can then pull in that information. But what it can also do is then allow us to do something about that information. So once I get those truck tags and I build my policy inside of FMC, I can then, if it violates my policy inside of FMC, I can then automatically go and quarantine that endpoint. So instead of waiting up to 100 to 200 days to figure out that my endpoints have been compromised, FMC will detect really rapidly that, hey, I've got an endpoint on my network that downloaded a malicious PDF. So ICE, what I need you to do is then quarantine that endpoint on the spot. So that is rapid threat containment. So it provides rapid response to threats and attacks inside of my network, and the indication of compromise goes down significantly. So PX-Grid, this rapid threat containment uses something called PX-Grid, but we also need to understand what that looks like, right? So PX-Grid is also known as Platform Exchange Grid. It is a solution in which we try to then share context information from our internal database context of the who, the what, et cetera, to our ecosystem partners, and then give them the ability to also provide context to us, right? So in this, for example, firepower, threat defense, and quarantine actions, okay? Traditional ways of integration, and some of our competitors do this too, is usually done via APIs, which traditional APIs, can be a challenge. They're not scalable, right? We have to wait for next releases because APIs can change, or we need to have, additional integrations or what have you. So that it doesn't allow us to scale. Using a protocol like PX-Grid, we can basically have this protocol out there and allow our ecosystem partners or other partners that want to integrate develop their PX-Grid clients and can automatically participate and scale inside the PX-Grid ecosystem. I'm trying to be knowledgeable of the time here, so I gotta hurry up here. So using PX-Grid, we provide a single framework for our ecosystem partners. We can share our context information, and it can be done bi-directionally. So not only is it client to controller, but we can not only communicating from our client to ICE, but you can have inter-communications between vendors as well using this PX-Grid ecosystem, which is the point that I want you to take away from this slide here. So the three things you can do is, again, PX-Grid provides the context, which can then send this information to our partners, which allows us to then create a single place for our ecosystem partners to then provide context back into ICE at the same time, right? And what this does is decreases time, effort, responding to security events and threats on the network. Okay. If you're curious as to how many people or how many companies and partners are integrating, well, we've got a number of them. We're at 40 and growing. Moreover, and we've got a lot more growing every day. So please check the slide later on when you get it later on to see how many integrations there are. I want to cover a couple of use cases before I go here real quickly. The ecosystem partners that I just talked about, they're at this URL. So when you get the deck, please click on it. And you can see all of our ecosystem partners, too, including PX-Grid, listed underneath our Security Technical Alliance program. So ICE, as you might be aware, we also include TACX support. So with that, not only do we do secure access control, but we also allow role-based access control for the management of those devices. So we've got a one-stop shop for not only access control, but also device management, and we can provide different levels of access based upon who you are as an administrator, whether you're security or your network admin. I want to quickly talk about deploying ICE and the personas, and it's kind of important to understand. We've got 4 personas. It's a policy service node, which is basically the workhorse of the deployment. It's the radius server, essentially. Our policy admin node, which is our single pane of glass and do all the administrative work for the deployment. Our M&T node is where all the reporting and logging takes place, as well as the PX-Grid controller. All of these personas can sit on a single standalone node, right? Or if we need to scale, what we can do is break those out into individual nodes that will allow us up to 500,000 concurrent endpoints. So we go from our standalone deployment, which is just 2, an HA pair that supports 20,000, all the way up to 500,000 endpoints, which is where we've broken out all the personas. It's 2 PANs, 2 M&Ts, and up to 50 PSNs. Okay. Just a quick look at licensing here. We've got 4 types of licensing. We got evaluation, base, plus, and apex. Evaluation just gives you the ability to kind of kick the tires on the product. Base provides a number of basic level authentication types, so including guest, easy connect, and trustsec. Plus is really your profiler and BYOD type thing, and then your Apex is your TC-NAC, posture, and mobile device management. Okay, so we've talked a lot about what ICE does in terms of, to provide simplified access across wired, wireless, and VPN. It does visibility. In addition to that, it does, reduces the risk because it does things like rapid threat containment as well as TC-NAC. So ICE does a number of different things to help with your network security needs. The last thing I want to talk about before I wrap up is software-defined access. So you've probably heard about DNA Center. ICE is actually at the center of that, and it's really reinforced because it's the policy portion of that. And if you try to go into the policy section of DNAC, you'll actually see ICE is not integrated if it's not set up, and it's required. So we've got that integration actually set up and working. You can see the security group or scalable group tags from ICE available. So what we do if we want to go ahead and set up our policies, what we can do is go ahead and build our fabric policies and then go ahead and save that. And what it does is DNA Center over APIs will then inform ICE to say, hey, here's my new policy. I need you to roll that out to the infrastructure. Okay? So if you need any more resources on ICE, please check out our communities, check out our design guide. There's a forum. We love to have questions. The TMEs monitor it from basically every day. Please go visit our community page and post questions there if you have any. And with that, I am all done.
All right. Thank you, Tim. Peter, it looks like you have the ball now.
Righty. Thank you, Tim. Thanks, Ernest. Let me get my stuff shared here, and I'll dive right in.
Great. Thank you.